So welcome everybody to Advanced IP Technologies for NREN Ambitions, presented by Bruno de Troch of Nokia. And I hope it's going to be a really interesting session, and I'm certainly going to be interested to hear what's going on in this area. So I'm now going to hand over to Bruno and leave the floor to him. Thank you.
Okay, thank you very much, Carl. So thanks for joining us for this webinar. It's my first time I will be presenting to this audience, so I hope it's going to be interesting. And as we already discussed just before we started, actually, I'll be at TNC. So if you have more detailed questions, of course, I can handle today, but otherwise we'll have plenty of time in Tirana to discuss. So my role in Nokia is a regional PLM. So I'm heading a team of people trying to gather requirements from the market in Europe, Middle East, and Africa, and then make sure that this is actually getting introduced in our products. I hear a bit of an echo, Carl, so I'm not sure if people are on mute. All right, so with that, let me start. So the presentation is about IP technologies. So I'm on the IP side of the Nokia house. So before I go into a bit more on the evolution we see on the IP side today, I will talk about Nokia very quickly, what we are today or who we are today. I think for most of you this is known, but still I encounter a lot of people who have a bit of a wrong view on where we are as a company, so I'll try to rectify that. The challenges I think that most of you are having in the research and education networking world, and then going into the meat of the presentation is of course on the IP technologies that I think are relevant for you, and then just end with two use cases, two networks that we've recently built or that we've built in the past, and that gives you an idea on where we are going with our in the IP world. So Nokia, I guess depending on your age, for most people, Nokia they know us from a small device that was called the 3210 or 3310, old days that we were doing mobile phones. So we are actually rebranded our company completely recently to be more matching what we're trying to be for the industry. And so the whole kind of Nokia connecting people tagline has gone for quite some time. So now we're really focusing on technologies that bring not only people but also things together. So trying to make the world evolve to a better connected place, and really focusing on B2B more than in the old days on the consumer market. And from that perspective, our focus is really on future-ready performance for networks, which have an impact at scale, and then offer collaborative advantage. Wow, that was difficult to pronounce here. Right, so that is what we are today. And in that context, as I told you, I'm on the IP side, so it might be worth knowing that we're actually one of the bigger IP players these days, right? So again, for this audience, I guess this is known, but nice to repeat. I think that especially in Europe, actually, we are leading the IP router market share numbers, right? You see a lot of customers being mentioned on this slide. Don't want to spend too much time on this. Reason I show this is to explain or to show that I think we are relevant, and because of that, more and more of our customers, more and more of the industry are listening to us on what we have to say on evolution of networks on the IP side. Right. So with that, moving to the other side, so on the REN challenges that we think you guys are having. Probably more than this, but if I take the more important pillars here, I think one is about network complexity, where we've seen your role changing over time, where traditionally it was more like a wide area networks, where of course the advent of cloud, data center in general, different types of traffic being carried over your network has added to the complexity of running the network itself. The second one is about scalability. Of course, your customers are getting more connected with more devices, which actually results in scalability, the scalability aspects becoming even more important than they were in the past, right? A bit of a consequence of that is because of the scale and that complexity that goes up. Of course, there is more interest in automation, and I must say, from my experience with NRENs in general, I think that that NRENs typically have been on the front runners of automation. If I compare with my my service provider customers, I must say that the feeling is really that NRENs are kind of ahead of many of the service providers when it comes to automation, much more open to new ways of managing the network and automating some things that were done manually in the past. And then a last component that is, or last challenge that I think you're all very busy with is of course the security side. More attacks happening continuously. So I guess that is top of mind for many of you. On security specifically, there is going to be another webinar later this year, so I'm not going to focus on that aspect specifically. So I'll focus more on the other your other challenges. Now, coming then to the technologies that we think are relevant on the IP side to research and education networks. First of all, is about solving this problem about scaling and complexity of network. We see a trend in the industry actually to go to more what we could call like SDN empowered technologies. Like segment routing is one of them, EVPN is another one. So segment routing for the transport layer, and then EVPN for your service layer. This is something that is gradually being introduced in many of the customers today, to the point that greenfield networks today that we design are typically based on these technologies, right? So of course, for brownfield, you can argue when it's the right time to migrate, when it's the right time to evolve the network to these new technologies, but for greenfield, there is no discussion anymore. Second aspect is coherent in general, right, where there is two aspects. So there is an evolution on the coherent side on optical transport, so that is one of the components, but at the same time, there is also an evolution of coherent on the routers themselves, right? So talking about 400ZR, 400ZR plus, so coherent pluggables that go into routers right away. Industry talking about 800 gig. There is a lot of hype, a lot of interest in the industry on these capabilities. So these things go a bit in parallel. So there is evolution onto the optical transport equipment, and at the same time, there is also evolution onto router pluggables into the same coherent space. Security side, I told you I'm not going to cover that here, but of course it's there. We also have solutions in that space when we talk quantum safe transport, DDoS detection and protection. Again, I told you that this is going to come, or it's going to be a separate webinar towards the end of the year. And then the last thing that we see as a bit in this, driven by this coherent evolution, coherent routing evolution that we see on the boxes itself, there is more and more interest from customers into IP-Optical coordination, where especially in service providers, these things are a bit disconnected. Typically, you have big teams in both areas. Again, in NRENs, I think there has always been a bit more interest in seeing how these things fit together because the teams happen to be smaller. So people look at both IP and optical, the optical side of network. Right. So a bit of a kind of a summary, or how does that translate into kind of a blueprint of the most networks that we're seeing, is that you have this common transport layer where of course there is multiple, that is kind of creating a fabric, an IP fabric, where you have multiple things being connected from data centers to the universities and laboratories and so on one side. And on the other side, of course, you have to provide connectivity to the internet, to public clouds, to other RENs. And then all of this needs to be managed together in the most consistent way possible. So this is kind of what we see on your side. And then I'll go into the technologies that I think is are helping you to maintain this network, to offer new services, go to higher speeds, and so on in the future. So this is a slide that from a Nokia perspective we're using quite often, but I think it's very, very representative for what's happening in kind of the IP router industry today. So there is typically, when we discuss evolution of networks and the individual components, a bit more focusing on the one now, is focus on three areas. One is what is happening on the silicon side, on the system side. So hardware-wise, decisions to be taken by service providers, by network operators in general today is, what is the chip, what is the forwarding plane I'm going to base my network on, right? What are the capabilities of that chip, what is the speed, and so on. So that is one for us. In Nokia speak, we call this FP, the name of our chipset, in the same way that you would be talking about Silicon One, or you would be talking about Trio or Broadcom. So all of these chipset options are there for us. For Nokia, we call this FP, and then the latest generation you have on the FP side is FP5, right? So I'll talk about, not specifically about FP5, but the evolution that allows us, or where we can go actually with FP5 capability-wise. The second big component is, of course, the operating system that runs on top of this hardware. So the hardware alone is a starting point. You need to have an operating system on top. So there is quite some evolution there on features, of course, because you build the networks a bit differently than 10 years, 15 years ago. There is functionality that you need to enable in software to allow a better operating of that network, to allow this new fabric design that we want to go to. And then the third component, becoming more and more important in networks that we're building today, is everything to do with automation, moving into a world that is driven by an SDN controller, where your traditional network management is evolving from just checking if your network is all right, to really the other direction as well, where the controller is deciding where the traffic is going, how the services are running on top of the network, providing an API to the outside world so that services can be much more dynamic than they were in the past, right? So that is the goal of the big network automation topic. So focusing a bit on kind of the data plane, so the evolution there, what we see is actually interesting puzzle or interesting challenge to most of our customers, is that your traffic is going up all the time. And that could be 30% per year, 40% per year, whatever. So this is a nice growing path that is, of course, exponential, that you see on the capacity side, that is in yellow on this slide. But at the same time, we have, as a community, we have actually a mandate to reduce our carbon emissions quite dramatically by 2030. That is kind of the first, let's say, the first deadline or the first goal. Also resulting in, so that capacity actually needs to, our carbon emission needs to reduce by 50%, right? So trying to combine these two things, where in the old days, more traffic meant more power that is consumed. Now we need to come up with solutions where more traffic doesn't necessarily mean also that the power goes up, right? So that is limiting our options. So what we think is a very important component in all of this is that you need to go to, of course, state-of-the-art technology on the data plane, and also to interfaces that allow you to be much more power-friendly, much more green than they were before. And so the technology, or the next available technology for that, is 800 gig. Now, purely on the topic of 800 gig, I can probably talk for like a half a day, but you could say 800 gig for me is maybe not relevant. It's not the type of traffic you have. You don't have that much yet, although with growth it can go quite quickly. And I know some of your customers are very kind of capacity or traffic consuming. So 800 gig might be there or not. But what is interesting about the 800 gig technology is that the first time that we developed, or the standardization has actually created an interface where also the sub interfaces are defined from the beginning. So that means that today, an 800 gig cage on a router, which exists today, you can actually use as 2 times 400 gig, or actually use as 8 times 100 gig to have a lot of kind of 100 gig density at a power level that is much better than the alternative where you use individual router cages for that, right? So imagine today you need 5 times 100, you will use 5 different cages on a router line card to do this 5 times 100. What we can actually do is combine this all in a cage. And of course, you need to think about redundancy. I understand all of these problems as well, of course, but from a power perspective, you can have a very big benefit there. Think 35% of the power of the optics is actually, or that reduction you can have by just moving to 800 gig much quicker, right? So it's and then the other aspect is, of course, cost. What is interesting about 800 gig today is if you take an 800 gig pluggable today, it comes roughly at the cost of 2 400 gig pluggables, which is also the first time in industry this happened, right? So when we moved to 100 gig introduction, 2010 more or less, we moved to 400 gig in 2015, 2016 timeframe more or less. The cost of that higher speed was always higher than the original alternative, which is not the case for 800 gig from the beginning. So 800 gig pluggables exist today. Actually, I will bring one with me at TNC. So if you want to touch one, that will be possible. So I'll bring this one so for you to experience kind of firsthand that this is existing today. So for us, important now to be able to allow this or to enable this into today's routers, there is a number of things that are needed. And one of the most important things for 800 gig transceivers enablement onto routers is that the router needs to be based on 100 gig SerDes. In what you see on the slide here is 112 gig SerDes, so that's the exact number. SerDes is the connectivity between the chips on your line card and also between the chips and the pluggables. Right? Now, what was defined in the standards is, or 800 gig is defined as 8 times 100 on the optical side. So your pluggable is actually creating 8 lanes of 100 gig wavelengths. These things on the router side, on the line card side, translate actually in these SerDes lines, so electrical lines that are also running at 100 gig. Right? So it's a very important component because it's also contributing to the power reduction here. A lane of 100 gig will consume much less than 2 lanes of 50 gig, right? So the higher speeds onto the line cards on the SerDes lines are actually contributing a lot to the benefits on the power side, right? So of course there is the silicon side as well. You need to have the forwarding chip to enable these higher speeds and to get to multiple 800 gigs at line rate, which is what most customers want, of course, or most networks are require. Another interesting aspect for routers today is the whole cooling aspect. If you look at, especially if you go to these higher speed optics, like the 800 gig, but also if you go to coherent interfaces like 400 gig, and later on next year, we expect actually 800 gig coherent into the routers, the cooling of these pluggables, which consume more power, this cooling of the pluggables becomes a problem on its own, right? So you need to have the right architecture on the line card to allow you to cool this additional, this kind of heat generators on your line cards, let's call it that, right? So, and one of the evolutions that we see in the market is that line cards will have to move at some point to the center of a slot. Why? Because you want to put your cages, your pluggables onto both sides to have better cooling across, right? So you see this in the drawing. So my airflow is much better because I can cool my two sides of the PCB in the same way. So it's one of these technical evolutions that you will see more and more coming onto routers, and that we have available on our systems actually. And then of course it's not only the line card itself, but it's the full system, including your switch fabrics, need to allow this traffic flow or this airflow through the system to optimize cooling. And the better you optimize cooling, the better your power consumption is going to be. If you do inefficient cooling, the consequence of that is that you have to run your fans faster. And the consequence of that is, of course, that your power consumption will go up, because fans are one of the most power hungry items onto a router these days. So coherent routing, I already mentioned it a few times. A bit hyped in the industry, where that new capability of having 400 gig 400 gig coherent directly onto the router has been talked about at many conferences. So for people not really following that, is today what you see on the left side is how conventional IP-Optical networks would work. So you have, let me change here my pointer. So the conventional way is where you have your router and you put like a gray optic into the router, like the one I just showed at 800 gig. And then you would have a transponder where that client interface is translated into a coherent interface, and then you go over an optical line system. Now, evolution of the technology makes it such that you can actually, that capability that used to be on the transponder can now be put onto the router itself. So you have a coherent interface directly into the router, right? Connecting directly into your DWDM layer, kind of bypassing the transponder. A technology that might be of interest as well to the REN community. Depends a bit on the size of your country and also the geography, how far apart the different cities or connections or POPs are into your network, right? So it's a technology that is part of the data plane. Because if my system doesn't allow the cooling of these coherent interfaces, or doesn't allow the density that is required, of course, it's not something that you can enable, right? So I've put that into my first pillar. Second pillar, as I said, is software that needs to run on top. What we see there is a bit of a, and so by the way, for people not very experienced with kind of in the Nokia language, so SROS is the name of our software, in the same way as you might be used to Junos or iOS. We have SROS, where SR stands actually for services router, so a router that is focused on services, which was actually from the beginning one of our focuses when we created our first routers. Now, if you look at the evolution of where typically the industry is spending cycles on the software side, there's a lot to do with, of course, segment routing, everything to do with SDN, EVPN, the services side, quality of service, the availability side, licensing flexibility, right? So trying to adapt more to the actual need of the customers, the DDoS protection. And then you have this model-driven programmability that has become key, I think, in the industry. Why? Well, at the end, we will all want to automate. There is going to be more devices, more faster kind of reaction of introduction to services, more dynamism in general. So automation becomes key. Now, automation is or starts from the router side, right? So the software running onto the router, of course, need to allow you to automate. And one of the enabling components to be able to get more efficient on the automation side is to create model interfaces between the router and whatever you have on the northbound side of the router. So with that, the kind of the framework of the future is really model-driven management, where the center is typically a young model or multiple young models that define everything from configurations and state and so on. So everything you do on the router is actually covered by a YANG model. Now, the YANG model could be something proprietary. Most of the vendors have capabilities that are not necessarily standardized. So that is a subset of all capabilities of the router. And then at the same time, you have quite a few parties who are creating standardized YANG models. If you take OpenConfig is a good example, but IETF is doing some models, BBF is doing some models. So quite a few of the standardization organizations are defining models for the industry. So for a router, it's going to be important to support both the standardized models, because these allow you to speak kind of the same language, the same models towards different vendors. And at the same time, also some defined or supplier defined YANG models. So that is really the focus for kind of a next generation operating system or network operating system. So these YANG models to have full coverage. And then you have different ways of communicating with these YANG models from the outside. You can use netconf or gRPC, GNMI to systems, or you can use a CLI, of course, to interact with the routers. That is also fully model driven, right? So that model of having all of that capability being based onto model driven, to have completely model driven, is really the way forward if you want to go to automation in the end, right? So what you see here, the router applications are actually the applications running on the router. Take BGP, your IGP, your QoS, your services, and so on. These are individual router applications for which you need, of course, configuration. You need to be able to configure them, but you also want to get state out of them because you want to do telemetry as an example. And then, of course, for operations, you also want to get information both ways there. Now, what we think is an additional component, and we see that also not only with us, but also some of our competitors, that more and more there is also interest to do some automation directly onto the router itself. So some kind of scripting, not kind of the traditional way on an offline system, but rather on the router itself for multiple purposes. People want to have some flexibility on the router itself. And so the model that you could imagine there, or at least what we have implemented, is actually Python directly onto the router, so that you can use Python to interface directly with these YANG models that you have onto the router, right? So that is that kind of that native access. But then a next step is, of course, that you need to be able to kind of launch these Python scripts, let's say from the CLI, right? So that you don't have to go off the system to be able to launch your Python script. So that is kind of the interaction between your scripting engine or your Python engine and the CLI itself, so that it's kind of fully integrated. And then the third step, where more and more customers are going, is to create your own customized CLI commands, right? So where actually a command is actually is a Python script that is running, but you completely integrated it. You integrate it in the CLI, so that people can actually launch it directly as if they were, as if it was a native command from the operating system. The advantage of doing that is that you can build in the flow that you take, like a troubleshooting flow that you would typically use onto a router, where you go one command, you look at the output of the command, and then based on the output that you're seeing, the operator does like a second command, again, taking the pieces that he finds interesting, and based on that, he will probably do like a third command. So like a whole flow of troubleshooting, you can actually build that flow now into the script, so that there is only one command giving you the relevant output. And you can see that you get much more, or you can get actually much more efficient by doing that, right? So it's something we've invested quite a bit. And again, we're not the only ones in the industry who have invested quite a lot in that automation area. So on automation in general, this allows you, this model-driven framework then allows you to work both on the network visibility, how well can I seed my network? What are the interesting components? Optimize my operations and so on. Get more information, get more telemetry out of my systems. And at the same time, there is people interested in, okay, what can I do more with this network programmability to maybe launch some services automatically based on what happens somewhere else and so on. So all of that capability is also of interest, of course, right? So not only visibility, but also kind of the programmability to differentiate from on the services, or to enable some services that otherwise would be very difficult to launch. So this is the router perspective automation piece, right? So where we've done a lot of things in the operating system to allow you to have that flexibility. And then if we move to the third component of my 3 pillars that I discussed, is in our case, this is called the NSP. It's just an example of a controller that in this case, it's our offering, but again, similar offerings from other suppliers, is that you want to have, instead of your traditional network management system where you can just do like your full FCAPs that you have maybe today or that you had in the past, you want to evolve this to a much more dynamic framework where it is easier to interact with different types of equipment and easier to interact with APIs to the external world. Right, so the architecture of such a platform is based on a lot of open standards, very open tools. In our case, well, Kubernetes, of course, but with a number of applications that we can run on top, but it also has the hooks towards external systems to allow you to extend it. Right, so you see kind of course, the data store with the time series database and so on. What you see on the system itself is a number of applications that will allow you to do path control, to do some automation with workflows, depending on some events in the network. You do actions directly onto the router, and then on the northbound, integration to other applications. Could be your own, could be other suppliers, other vendors, like an OSS type of system. And then on the southbound, more and more capability to talk to multiple vendors, right? And you see, well, of course, we have Nokia here because we support, of course, our own equipment, but at the same time, we have customers using our NSP to also manage a Juniper or some Juniper devices they might have in the network, Cisco devices, and so on. This is for other IP equipment, but we go even one step further that we can talk, and then the protocol of use there is TOPI, the TOPI interface, which can be used to talk to SDN controllers from optical vendors and creating a full IP-Optical integrated solution, right? So we see, again, the basis is a framework where we provide a lot of components, but that allows enough flexibility to integrate to other systems that you might have, or other solutions that you might have into your network. And so this is just an example, again, coming back onto my Coherent pluggables, because it's a hot topic. So this is one of our blueprints that we are discussing with customers, where what you see here, it's a bit overloaded maybe, but what you see here is on the light blue side, it is components that are typically coming from the IP side, right? So I have my routers, I have my Coherent pluggable, so the 400 gig ZR or ZR Plus is integrated, is plugged into my router. I have a management system, in our case NSP, that goes on top here, that is managing and controlling the two routers here. But then the problem with these pluggables is that I cannot just configure this from an IP perspective, because the impact of changing frequencies, changing kind of the power levels and so on, might have an impact on the analog world, on the optical world, on other links and so on. So ideally, want the optical parameters being configured by an optical controller. And that's exactly what you see here, right? So we use our optical controller to kind of manage the end-to-end path, could be including so the path could be including the pluggables here on the routers, but could be separate transponders as well. So the optical controller is managing the optical domain and then is using this TAPI interface towards the IP controller to exchange all of that information, so that the bring up of a new interface of services and so on is consistent, and both the IP team and the optical team are actually getting a common representation of the world, even though they don't touch the same systems, right? They are actually having a consistent view, right? So that is, I think, one of the requirements when you go to coherent pluggables into routers. You cannot just do that by putting the pluggable into the router and then pray that the signal will get to the other side. It will have, of course, side effects on the rest of the optical network. Now, once you go there and then you say, okay, now I need to be able to do IP-Optical anyway for my coherent pluggables, if that makes sense into your network. Then the next step is, of course, to look at other things that you can use on this IP-Optical integration. And this is, again, a capability in our case from NSP, where because we see both worlds, you can start to do correlation, kind of errors that are happening on the optical side. What is the effect of these errors onto the IP side? Or vice versa, I have a new IP service, or I offer like a new EVPN. How can I make sure that there is no single point of failure, not even on the optical side? What we see with many customers is that they create this diversion or diversive paths onto the IP layer, but at the end they go into the same, this traffic goes into the same ducts on the optical side, right? So by having that visibility across for both IP optical, you can actually avoid these single point of failures, and you can do coordinated control, for instance, so that you know when there is some works to be done on the optical side, there is maybe change of lambdas or whatever, or a new duct and so on. You can actually see the impact on your IP services, and so many more things, right? So if you have both worlds to take into account, there is more use cases that you can offer, of course, right? So it's something that we're discussing more and more with customers, where, of course, the whole efficiency aspect is becoming important. Just an example of this, right? What you see on the drawing is, or on the graph on the chart is an output from our tool here, where you see some routers and some optical equipment exactly into the same view of the world, right? So you would even easily be able to see a single point of failures, how the traffic would be flowing. You can actually see that end to end, not only on the IP side, but also including the optical side. And then you can see the multiple layers, how the kind of your EVPNs or your VPNs are running on top of this multi-layer network, and trying to optimize the full redundancy for end-to-end, for instance. So with that, I hope I gave you a bit of an overview where the industry is going, not trying to focus too much on the Nokia solutions, but rather into the bigger context of the industry. Last slides I have are more about the two use cases, right? I started with our kind of our credibility in the ISP space, and then specifically for NRENs, we do have a number of customers already, and so I'm going to give two examples to kind of to set your mind. On one side, I have Acconet in Austria, where both IP and optical networking solutions are there. So on the IP side, we have the SR family, and on the optical side, we have the 1830 PSS, right? So on the WDM side, and at the same time, they also have, of course, the management systems that go there, right? So it's a end-to-end network, IP optical, where question that I got, maybe it's a good time to kind of mention that. A question that I often got from customers is, okay, what are my benefits to bring IP and optical from the same vendor into my network? And then of course, everything is standardized, and that is fully true. So if I take TAPI, for instance, as an interface, we have demonstrated interop TAPI with other vendors like Ciena and Infinera on the optical side. However, I think where the difference is that what we're also doing is creating blueprints for end-to-end networks these days, where we have a lab, of course, with both IP equipment, optical equipment, and then we try to see if everything works all right. So that creation of blueprints is very difficult to do in a kind of a multi-vendor environment. So one of the benefits is, of course, that you can use the blueprints that we have for both IP optical combination into the same network, right? So Aconet is a good example of that. And then the last one I have is ESNet, based in the US, but I think they have also quite some presence in Europe. I met with them at the Nordinet conference in September last year. So this is focusing on the IP side, where ESNet actually selected our FP5 silicon, which is the latest generation of our IP chipset, with the idea to offer actually 400 gig access from the beginning, but really with the idea to go to 800 gig interfaces in the future. And that is kind of the advantage that you have today if you put these solutions into your network, that it is 800 gig capable. Not necessarily something that you need this year, maybe not next year, but knowing that these devices can do 800 gig without changing any hardware, right? It's not that we can support 800 gig in the future with a new line card. No, you can have it today. The only thing that will change is the pluggable, right? So a pluggable, so a cage today, you can put a pluggable even of 10 gig or 25 gig, 50 gig, 100 gig, and then and 200 gig, 400 gig. But then maybe 2 years from now, you will be able to use the exact same router interface, put in another pluggable, and then get 800 gig out of that, right? So without changing anything of the hardware, not the line cards, not the fans, not the power, and then you can evolve to higher speeds whenever you need, right? So not only you will get the power benefit from the beginning, right? So you're already kind of more sustainable from the beginning because of the evolution of chipset is using less power. But at the same time, the fact that you don't have to swap out too many components and you can reuse the existing components, of course, has a big impact as well on the sustainability side, because changing devices, of course, has also a cost sustainability wise. So with that, Carl, I've been talking for roughly 45 minutes, which allows me to get a bit more, get a bit of time for people to ask questions. I'm not sure how you typically do that. You open the floor or they ask them in the chat. Up to you.
Thank you very much, Bruno. That's been really interesting. And it's really interesting, particularly at the early stages when you're talking about the differences in power, and it's you know, it's really notable that, you know, although we continue to go up and up and up in bandwidth, that also implies we're also going up and up in power as well. So yeah, it is fascinating in that respect. So what I'm going to do is I'm going to stop sharing the screen.